Now, can take one more problem on eigenvectors and eigenvalues. Find the latent roots and the latent vectors, means eigenvalues and eigenvectors of matrix A equal to, let me take this, 6 minus 2 2 minus 2 3 negative 1 2 minus 1 3 2 minus 1 3. Solution. To find the eigenvalues, first we have to consider the characteristic equation of the matrix A. Characteristic equation of the matrix A. So first write the characteristic equation of A is determinant of A minus lambda I equal to 0. Determinant of A minus lambda I equal to 0. So that is what? That implies determinant of, from the diagonal positions I have to subtract lambda. So 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda equal to 0. If I expand this is 6 minus lambda 3 minus lambda 3 minus lambda 9 plus lambda square minus 6 lambda minus 1 minus of minus plus 2. This one goes, so this is minus 6 plus 2 lambda and this is plus 2, and plus 2 into last one, this is 2 minus 6 minus 2 means plus 2 lambda equal to 0. If any corrections, suggest me immediately. This is 6 minus lambda, this is lambda square minus 6 lambda plus 8, plus what about this 2 lambda minus 4. So 2 into 2 lambda minus 4 plus 2 into this is 2 lambda minus 4 equal to 0, right? So I can write 6 minus lambda, and for factorization I can write this is lambda minus 4 into lambda minus 2. Next plus, this is, I can take 2 common, lambda minus 2. 2 common, yeah, anyway both are same, 2 2 4. This is 8, I can write equal to 0, right? Now what is the common? Lambda minus 2 is the common. So remaining part is what? 6 minus lambda into lambda minus 4 plus 8 equal to 0. Plus 8 equal to 0. So this is equal lambda minus 2, and if I multiply this is 6 lambda minus 24 minus lambda square plus 4 lambda plus 8 equal to 0. So this is lambda minus 2 into minus lambda square 6 plus 4 plus 10 lambda 24 minus 16. Is it correct? Yeah, equal to 0. So take minus common, lambda minus 2, and what is this is lambda square minus 10 lambda plus 16 equal to 0. So this is minus lambda minus 2 vector factors, lambda minus 2 into lambda minus 8 equal to 0. So what are the eigen values of lambda? 2 to 8. 2 to 8 are the eigenvalues. Are the eigenvalues or latent roots? Okay, now corresponding to say here 2 is the, since lambda equal to 2 repeated twicely, the algebraic multiplicity of lambda equal to 2 is 2. Lambda equal to is 2. Okay, next one. Coming to eigenvectors. So case 1, first lambda equal to 2. For lambda equal to 2, then consider the system. How to calculate eigenvectors? Consider the system. What is the system here? A minus lambda I into x equal to 0. A minus lambda I into x equal to 0. And A minus lambda, the matrix. What is that? 6 minus lambda. In that one, put lambda equal to 2. So what is this becomes? First one is 6, 6 minus 2, 4. Remaining positions are same. Negative 2, 2. Next. Minus 2. 3 minus 2, 1. Negative 1. 2 minus 1. 3 minus 2, 1. Into x equal to 0. Okay. Now convert this to echelon form. To convert this echelon form, I have to reduce this to 0, this to 0. Isn't it? 2r2 plus r1, first operation. 2r3 minus r1 is the next operation. Then what is this becomes? 4. Negative 2, 2. This is 0, 0. And coming to this. Plus 2 minus 2, 0. This is minus 2 plus 2, 0. Coming to this. Minus 2 plus 2, 0. This is 2 minus 2, 0 into x equal to 0. Okay. This is in echelon form. This is in echelon form. Is it correct? This is in echelon form. Therefore, what is the rank of the matrix? Number of non-zero rows. Only one non-zero row is there. And how many unknowns? Three unknowns are there. The number of unknowns. The number of unknowns. Okay. In the last class, we have repeated eigenvalue, but there are no 2 zero rows. Here we are getting now 2 zero, the number of unknowns. Therefore, there exists non-zero solution. Homogeneous system. Okay, there exists non-zero solution in which how many independent variables exist? In which 3 minus 1 equal to 2 independent variables exist. 2 independent variables exist. Okay, got it. Now the echelon form gives. Write the echelon form into system of equation. The echelon form gives. What is this echelon form? 4 minus 2, 2. 4 minus 2, 2. 0, 0, 0, 0, 0, 0. And let me consider this capital X as x, y, z equal to 0. Done? Now, this is C. How to calculate? What is the system becomes? 4x minus 2y plus 2z equal to 0. Only one equation is there. Since there are two independent variables, okay, we first choose generally. What is our previous technique? All of you remember? Is voice is visible now? All of you, are you getting?
Yes, sir, visible.
Yeah. Now, from this step, very important. Listen, all of you. Since there are two independent variables, what we have taken previously in previous methods, we have taken let y equal to some k1, z equal to k2, isn't it? Then what about x equal to this is 2 gets cancelled. So this one you will get k1 minus k2 by 2. K1 minus k2 by 2. K1 minus k2 by 2. Then what happens after assuming these two, y1 and y2, k1 and k2x, then you choose any one. Then you choose values of k1 and k2 arbitrarily. You put 1 or 2, whatever it is. Then you will get solution. Okay. Still they are joining. What you are doing? Oh, who is Mizam Rajvi? Speak out. Then what is this solution vector? Eigenvector is what? Capital X1 equal to k1 minus k2 by 2. Next k1, next k2. Now you choose some k1 equal to some 1, k2 equal to some 10, like that. You will get corresponding eigenvector. But the thing now here is, we first choose, I have to get what? 2 linearly, well, see, logic is what? When there are 2 zero rows in the matrix, there are 2 zero rows in the echelon form, definitely we will get 2 linearly independent eigenvectors for the repeated eigenvalue lambda equal to 2. In the last class, we are having repeated eigenvalue. One by eigenvalue is repeated 2 times, but we are not getting 2 0 rows there, only 1 0 row. That gives only one independent eigenvector. But in this problem, we are having 2 0 rows. That means there is a possibility of getting 2 independent eigenvectors. How? That is the process here now. We first choose, I will choose y equal to 0. I first choose y equal to 0. Then what happens then? 4x plus 2z equal to 0. 4x plus 2z equals to 0. Then I can write this is x equal to what? Minus z by 2. Is it correct? Yeah, x equal to minus z by 2. So I can write this is, so I can write, therefore I will write x by 1, y value 0 and z value minus 2. Therefore first eigenvector is x1 equal to 1 0 minus 2. Why I am taking 0? Let us see. It will be clear in the next step. Secondly, we choose now. Secondly, I can choose any two variables as independent. Secondly, we choose z equal to 0. Then what happens? 4x equal to 2y you will get. 4x equal to 2y you will get. Then x equal to y by 2. Therefore, what we have, x equal to y by 2 means x by 1, y by 2 and z by 0. Therefore, the second eigenvector is x2 equal to what? 1 2 0. Now tell me what is x1 here. I am clearly writing here. x1 equal to what is the first eigenvector? 1 0 minus 2. 1 0 minus 2. x2 equal to 1 2 0. Clearly tell me, is these two vectors depends on each other? Anyone? That means is one vector is obtained from the other by any multiplication constant multiplication? Anyone?
No, sir.
No,
Or
sir,
clearly
independent.
linearly? Yeah, clearly linearly independent. These are linearly independent. Is that clear? So why I am choosing 0 means here there is a 0. In the second position here there is a 0. But in the here third position 0. Therefore obviously these are independent vectors. That is the logic of choosing z equal to 0 and y equal to 0. Why 0, sir? I can choose anyone. Choice is yours. You can choose anyone. Okay, like this. This one k1 k2 you can give any values for k1 and k2 and to get some particular eigenvector. This is the process to get linearly independent. And remember, the important point is what? When eigenvalue is repeated 2 times, then in its echelon form there must be 2 0 rows. 2 0 rows. Then only we have 2 linearly independent eigenvectors. Otherwise it is not possible. Like previous class. Now these two is over. Now case 2. Lambda equal to what is the another one? Lambda equal to 8. Lambda equal to 8. For lambda equal to 8, consider the system a minus lambda I into x equal to 0. That means a minus 8i into x equal to 0. And what is the matrix? A minus this one, 6 minus 8 minus 2 minus 2 2. Next one minus 2 3 minus 8 minus 5 minus 1 2 1 3 minus 8 minus 5 into x equal to 0, right? Then what is the operation echelon form? R2 minus R1 R3 plus R1 minus 2 2 0 0 minus 5 plus 2 minus 3 minus 1 minus 2 plus 1 minus this is negative 1 and minus 5 plus 2 minus 3 into x equal to 0. Next step, convert this to 0 using this position. So 3R3 minus R2. Then 3R3 minus R2, right? Minus 2 2 0 minus 3 minus 3 0 0 and what about this? Oh, some mistake is there. I did one mistake because definitely I have to get a 0 row. That's compulsory. Where is the mistake? 3 minus 8, 3 minus 8. This is negative 1. This is minus 1, right? Now this is minus 1 means minus 1 plus minus 5, minus 6. See, one simple mistake. And what is the operation now? Not this is the operation. Okay. What is the row operation? R3 minus 2 R2. Now, this is also mistake again. Now, with this operation, what happens? Okay. There is also this minus 1, minus 6. This is minus 6. So now this is 0. So what is the rank? Rank is equal to 2 less than 3. The number of unknowns. Less than 3, the number of unknowns. Therefore, there exists non-zero solution. There exists non-zero solution in which 3 minus 2 equal to 1 independent variable exists. One independent variable exists. This one independent variable gives independent eigenvector. And what is echelon form? Echelon form gives, I'm writing directly, minus 2x minus 2y plus 2z equal to 0 minus 3y minus 3z equal to 0. So from the second expression, what I'm getting, this is y equal to minus z, one thing, right? Y equal to minus z. Then what about this? Minus x minus y plus z equal to 0. This implies minus x plus z equal to 0. So x equal to what? 2z. Now let me combine these two. Now minus y equal to z, this one, and x equal to 2z. No, not x equal to z. I will write for z. X by 2 equal to 2z. This is x by 2 equal to z gives, let us write this one for z. Okay. Then what is this becomes? X by 2, y by minus 1, z by 1. See, x by 2 equal to z. Y by, this is minus 1, y by minus 1 and z by 1. Therefore gives, therefore third eigenvector is x3 equal to 2 minus 1, 1 is the eigenvector. Is the eigenvector. Okay, this is one model. Next, let me take one note. So one by one note. First one, for distinct eigenvalues, the eigenvectors are linearly independent. No need to check directly. Definitely they are linearly independent. That means if eigenvalues are, for example, 2, 3, minus 6, they are distinct eigenvalues. Then definitely you will get eigenvectors as linearly independent. Second one, for a repeated eigenvalue, the eigenvectors are linearly independent only when in the echelon form. Only when in the echelon form, the number of zero rows, is equal to the number of repeated is equal to the repetition number repetition number of eigenvalue. This is important. Eigenvalue. Otherwise, linear eigenvectors are linearly dependent. And one more important point here, what I have written, lambda equal to 8 is our right. Ikkada, one more point. Since there exist two linearly independent eigenvectors for the repeated eigenvalue to the geometric multiplicity of lambda equal to 2 is 2 here. Lambda equal to 2 is 2. If we get two linearly independent eigenvectors for a 2 times repeated eigenvalue, then geometric multiplicity is 2. Yeah, this is one model problem. Do you want more number of problems in eigenvalues, eigenvectors? Anyone? Yes? Anyone?
Sir, if there are any new models, explain, sir. Otherwise, no.
New models means I didn't touch the distinct eigenvalues. Do you want? Not repeated eigenvalues. You want a?
Explain one, sir.
Okay.
Sir, I have a doubt, sir.
Yeah, tell.
Sir, in eigenvectors, any one of the terms should be 0, sir.
No, any?
One of the 3 terms, sir. It must be 0 or no need?
No need.
Okay, sir.
All should not be 0. If I write x1 equal to 0, 0, 0, it is wrong. Because what is eigenvector? It must be non-zero. Definitely.
Okay,
Any
sir.
one value may be 0. Any more? I need anyway solved problems you can check in the textbook. Let me take another one. 201. I'm trying whether if we get distinct, that's okay. 0 2 0 1 0 2 1 0 2 solution. The characteristic equation of the matrix is the characteristic equation 1 o'clock. Characteristic equation of A is determinant of A minus lambda I equal to 0. Determinant of A minus lambda I equal to 0. Then that implies determinant of A minus lambda I means what? From the diagonal positions I have to subtract, that is 2 minus lambda 0 1 0 2 minus lambda 0 1 0 2 minus lambda equal to 0. Oh, this is what 2 minus lambda into 2 minus lambda whole square minus 0 plus 1. This one gone. This is 0 and this is minus of 2. What I am getting? Let us see. 2 minus lambda whole cube minus 2 minus lambda. Is it correct? So 2 minus lambda is common. 2 minus lambda whole square will be there. This is 2 minus lambda square minus 4 lambda plus 3. So this is 2 minus lambda. What about this lambda? Sorry. What are the factors? Lambda minus 1, lambda minus 3. Is it correct? This implies lambda equal to 1, 2, 3 are the eigenvalues. Not repeated. Okay. Now one by one. Case 1, for lambda equal to 1, consider the system. A minus lambda I into x equal to 0. That is A minus I into x equal to 0. That means lambda value 1. Substitute lambda value 1 in this matrix. That's enough. Okay. So what this becomes, this is matrix is what? 2. Okay. 1 0 1 0 1 0 1 0 1 into x equal to 0. Now echelon form means R3 minus R1. R2 position is already 0. So 1 0 1 0 1 0 0 R3 minus R1 0 0. This is echelon form, right? Is in echelon form. Is in echelon form. Therefore, what is the rank value? 2 less than 3. Non-zero solution, one independent variable exists. Therefore, echelon form gives, I am writing directly, x plus z equal to 0, y equal to 0. That is, y equal to 0 and x equal to minus z. This implies what? I can combine these two as x by 1, y by 0, z by minus 1. Therefore, eigenvector x1 is 1 0 minus 1. 1 0 minus 1. First one is over. Case 2. For lambda equal to 2, consider the system. Consider the system A minus lambda I into x equal to 0. A minus 2i into x equal to 0. So what does this becomes? This is 2, lambda equal to 2. So 0 0 1 you will get, 0 0 0 you will get, 1 0 0 you will get. Is it echelon form? Is it echelon form? 0 row is here in the second one. So take it into bottom. So whatever the operations, 1 0 0 0 0 1, this is 0 0 0. Corresponding operations you write. This is equal to 0. Using row operations you write. Using row operations we have now equal to 0 is in echelon form. Is in echelon form. Therefore, what is the rank here? 2 less than 3. Non-zero solution, one independent variable exists. So echelon form gives, what is the system? This is x equal to 0. Second one, z equal to 0. Second one, z equal to 0. What about y? What about y? Y is arbitrary, isn't it? One independent variable exists. One independent variable exists. Okay. Therefore, y is arbitrary. Let y equal to something, k, your choice. Therefore, x2 equal to, what is this? 0, k, 0. In particular, you can assume any value, doesn't matter. Is the eigenvector. Is the eigenvector for k equal to 1. And one more important point, let me tell here itself. I make a note now. Where is that note? Here. Third note. Eigenvector for a eigenvalue is not unique. Is not unique. Okay. This clearly shows k is arbitrary constant. Therefore, if I take k equal to 2 0 2 0 is another eigenvector. So I am giving here also one note. If for lambda equal to something, say for example, so for lambda equal to, just this is idea only, note, if for lambda equal to 2, x1 comma x2 are eigenvectors. x1 comma x2 are eigenvectors, then and see, for lambda equal to 2, x1 is eigenvector, x1 is eigenvector, then k into x1 is also eigenvector, This is one important point. And one more. If for a repeated eigenvalue, for example, this is only for example, if for example, for a repeated eigenvalue lambda equal to 2, x1 x2 are eigenvectors, then some constant c1 into x2 plus c2 into x2 is also an eigenvector. These are all gate points, gate examination questions previously. Okay. Now here x2 is the eigenvector, means constant into x2 is also some another eigenvector. Now coming to third case, case 3, lambda equal to 3. Consider the system a minus lambda I into x equal to 0. That implies a minus 3i into x equal to 0. Okay. Then what happens? This is matrix A minus 3i means what? What is the matrix 2 now? 2 minus 3, 0, 1, 0. 2 minus 3 means minus 1. Minus 1, 0. 1, 0, 2 minus 3, minus 1 into x equal to 0. So what this gives, echelon form means what? R3 plus R1. Minus 1, 0, 1, 0, minus 1, 0, 0, 0, 0. That's it. Echelon form is in echelon form. Therefore, what is the rank? 2. Less than 3, one independent variable exists. And echelon form gives minus x plus z equal to 0. So x equal to z. And next minus y equal to 0. Therefore, combining this, x by 1, y by 0, z by 1. So therefore, x3 equal to what is the third eigenvector? 1, 0, 1 is the eigenvector. Okay, these are the problems based on eigenvalues and eigenvectors. Take assignment. Find eigenvalues and eigenvectors. Eigenvalues and eigenvectors of first matrix A equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Second one, A equal to 2 1 minus 1 1 1 minus 2 minus 1 minus 2 1. Okay. And the third one, minus 2 2 minus 3 2 1 minus 6 minus 1 minus 2 0. Next one, fourth one 3 1 4, no, not this, 1 1 3, A equal to 1 1 3, 1 5 1, 3 1 1, 3 1 1. These are the exam assignment problems for eigenvalues and eigenvectors. Now, properties of eigenvalues. Properties of eigenvalues. First one, if lambda is eigenvalue of A, then 1 by lambda is an eigenvalue of A inverse. A inverse. Proof. These eigenvalues, properties of eigenvalues are important for short questions. Since lambda is eigenvalue of matrix A, we have, see, for which system we said lambda is eigenvalue of matrix A? For the system Ax equal to lambda x. Always keep in mind, this is very important. When we write Ax equal to lambda x means this lambda is eigenvalue of matrix A. This lambda is eigenvalue of the matrix A. Okay, once again, Ax equal to lambda x. This lambda is eigenvalue of A, and this x, both sides x is there. Don't cancel this. These are matrices. Okay, this x is called eigenvector. Okay, and I'm telling what is this? This is eigenvalue, and this x is called eigenvector. This is the notation. Remember always. What is that? When lambda is eigenvalue of matrix A, then we have Ax equal to lambda x, right? And what we have to prove now? 1 by lambda is eigenvalue of A inverse. Therefore, what structure we must have? This is Ax equal to lambda x means what? Lambda is eigenvalue of A. Now what I have to prove? 1 by lambda is eigenvalue of A inverse. Therefore, I have to get here 1 by lambda and here A inverse. I have to get A inverse here. So the logic is multiplying, pre-multiplying. In matrices, pre-post multiplications are there. Pre-multiplying, take this as 1. Equation 1 by A inverse. By A inverse. Then 1 implies A inverse into Ax equal to A inverse into lambda x. A inverse into lambda x. What is this? Is A inverse into A into x I can write. Since lambda is the constant, I can write anywhere. Lambda x in brackets by associative property. Matrix product is associative by associative property. This is I x equal to lambda into A inverse into x. Therefore, take this lambda this side. 1 by lambda Ix equal to A inverse x. 1 by lambda I into x is nothing but what? I into x is nothing but x equal to A inverse x. A inverse x. That is, I can write this one A inverse x equal to 1 by lambda x. Therefore, what is this? Is A inverse 1 by lambda. Clearly, therefore, 1 by lambda is eigenvalue of A inverse. 1 by lambda is eigenvalue of A inverse. Okay. Same, second one. If lambda is eigenvalue of A, then lambda power m is eigenvalue of A power m. And one more important point here, 1 by lambda is eigenvalue of A inverse. And is there any change in x? There is no change in x. X is eigen vector of 1 by lambda. X is eigenvector of 1 by lambda, and that X is also eigenvector for lambda. You try this. All of you try this. What you have to prove? I'm giving here. We have to prove that a power m x equal to lambda power m x. Try this. Oh, internet gone.